we are given f of x equals the 8th root of x cubed times the square of x minus 3, and asked to determine their critical numbers. If f of x is defined at x equals c, and f prime of c equals 0, or f prime of c is undefined, then x equals c is a critical number. Which means to determine the critical numbers, we first determine the domain of the given function, then determine where the first derivative is equal to 0 or undefined. And the reason we care about critical numbers is that if the given function does have relative extrema, they will occur at the critical numbers. Analyzing the function, it's important to recognize here the radical has an even index, which indicates the radicand must be non-negative, or in this case, x cubed must be greater than or equal to 0. And if x cubed must be greater than or equal to 0, then we know that x must be greater than or equal to 0. And then the square of x minus 3 adds no additional restrictions, and therefore the domain is x greater than or equal to 0, or if we want to give the domain using interval notation, we would have the interval from 0 to infinity, where the interval is closed on 0, meaning the interval includes 0, and the interval is always open on infinity. It's important to always find the domain first because if we determine the derivative is equal to 0 or undefined at a negative value, we would not include it because there are no negative values in the domain. The next step is to determine the first derivative. Before we do this, though, let's write the 8th root of x cubed using the irrational exponent of 3/8. We can write the given function as f of x equals x to the power of 3/8 times the square of x minus 3. Notice to find the derivative, we will have to apply the product rule, where the derivative f prime of x is equal to the first function of x to the 3/8, and then times the derivative of the second function, which gives us a derivative of the square of x minus 3, and then plus the second function of the square of x minus 3, times the derivative of the first function, which is the derivative of x to the 3/8. And now let's work on determining the two derivatives. We have f prime of x equals x to the 3/8 times the derivative of the square of x minus 3 is equal to 2 times the quantity x minus 3 to the first times the derivative of x minus 3, which is just 1. Notice how here I did apply the chain rule, which really wasn't required because the derivative of the inner function is equal to 1. And then we have plus the square of x minus 3 times the derivative of x to the 3/8, which is 3/8, times x to the power of 3/8 minus 1, which is negative 5/8. Let's clean this up and write this using positive exponents. For the first product, we have 2 x to the 3/8 times x minus 3, and then we have plus 3 times the square of x minus 3 divided by 8 x to the power of 5/8. Notice how I moved x to the power of negative 5/8 to the denominator with the 8, which changed the exponent to positive. And now to find the critical numbers, we need to determine where the derivative is equal to 0 or undefined. Notice how here when x equals 0, we have division by 0, which is undefined, and therefore x equals 0 is a critical number. Also notice 0 is in the domain. So let's keep a list of our critical numbers. So far we have x equals 0, and now we set the derivative equal to 0 and solve. And now from here to solve the equation, let's clear the fraction from the equation by multiplying both sides of the equation by 8x to the 5/8. On the left of the first product, we have 8 times 2, which is 16, and then x to the 5/8 times x to the 3/8 is x to the power of 5/8 plus 3/8, which gives us x to the first, or just x. Then we have times a factor of x minus 3, and then plus for the second product, 8x to the 5th divided by itself simplifies to 1, leaving us with just 3 times the square of x minus 3. On the right, we have 0. For the next step, let's factor out the greatest common factor from the two products which is x minus 3. So we factor out x minus 3. Notice how we're left with 16x and then plus 3 times 1 factor of x minus 3 equals 0. And now to clear the parentheses within the second set of parentheses, which gives us the quantity x minus 3 times 16x plus 3x minus 9, and 16x plus 3x is 19x, giving us 19x minus 9 equals 0. Again, if I lost you there, we have 16x plus 3x minus 9, giving us 19x minus 9. And now the product on the left is equal to 0 when x minus 3 equals 0, or when 19x minus 9 equals 0. Solving for x, we have x equals 3 here, or solving for x here, we add 9 to both sides and then divide by 19, which gives us x equals 9/19. Notice both x equals 3 and x equals 9/19 are in the domain of the given function, and therefore we have two more additional critical numbers. The critical numbers are x equals 0, x equals 9/19, and x equals 3. Which indicates if the given function does have any relative extrema, they would have to occur at these critical numbers. So before we go, let's look at the graph. Analyzing the graph, at the critical number of x equals 0, we don't have a relative minimum here because remember, x equals 0 would have to be in some open interval, meaning we'd have to be able to approach x equals 0 from the left and right. So we don't have a relative extrema at x equals 0, but we do have a relative maximum at x equals 9/19, which is approximately 0.474, this point here. And we can also see we have a relative minimum at x equals 3. I hope you found this helpful.